If r vector is given to us, we need to find derivative of r with respect to t and double derivative of r with respect to t. So let's find first the derivative of r vector with respect to t. Now since these are constant vectors, so their derivative are equal to 0, right? So let's differentiate this with respect to t now. First function, derivative of second, that is 0, plus second vector, derivative of first. Similarly for the second term, writing t² plus t plus 1 and the derivative of j vector with respect to t, that is again 0, plus the vector j and derivating t² plus t plus 1 with respect to t. Similarly for the third one, this term is 0, this term is 0, and we simply derivate this now. So this is I vector into 1 plus derivating this j vector into, what is the derivative for this? It is 2t plus 1, right? So it is j vector into 2t plus 1 plus derivating this with respect to t, we get 3t² plus 2t plus 1 and then multiplied with k vector. So this is 3t² plus 2t plus 1 and writing here the k vector. Let me write j vector after this and also I vector after this. So this is I vector plus 2t plus 1 j vector plus 3t² plus 2t plus 1 k vector. This is dr by dt. Now second, we have to take the double derivative of r vector with respect to t. For that, we need to just differentiate this equation with respect to t again. So that means we have to derivate dr by dt. So derivating this, we get 0 plus derivating this with respect to t, we get 2j vector plus derivating this with respect to t, we get 6t plus 2 k vector. So we are getting the answer to be 2j vector plus twice of 3t plus 1 k vector, right? Okay, next question. If r vector is this, we need to find the first derivative of r, the second derivative of r, then we have to take the modulus of the first derivative and modulus of the second derivative. R vector is given to us. Simply first we are going to find the derivative of r with respect to t. So this is cos of t I vector plus minus sine of t j vector plus k vector, or it can be written as cos t I vector minus sine of t j vector plus k vector, right? And now we have to take the modulus of dr by dt. So that will be equal to sum of the squares of the components of dr by dt. So writing the coefficient of I vector, taking the square, plus writing the coefficient of j vector, taking the square, plus writing the coefficient of k vector, taking the square. So that will be equal to under root, this is cos square t plus sine square t plus 1, and that is equal to, by using the identity, this is 1 plus 1, that is equal to square root 2. Then third part, we need to take the second derivative of r vector with respect to t. that is d by dt of dr vector with respect to t. Derivative of r vector with respect to t. So that is equal to, we need to derivate. Okay, what is dr by dt? It is cos t I minus sin t j plus k. So derivating this, we get minus of sin t I minus of cos t j plus derivative of this is 0. So we have this only. And now taking the modulus of the second derivative of r with respect to t, so that will be equal to the square root of sum of the components of d square r by dt square. So minus of sin t whole square plus minus of cos of t whole square. So this is the square root of sin square t plus cos square t, and that is equal to square root of 1, which is equal to 1. So this is how we solve such kinds of examples. Okay, thank you.